5% of those 100.
So a 5% chance of occurrence. So everybody's heard things like this before, right? There's a 5% chance, there's a 99% chance, and so forth and so on. Let's start getting a working knowledge of what that means right now. And I love what you just said, Faith. It's perfect. Did you hear what you say it one more time for us?
If you had sets of 5s and you did that set of 5 100 times, only 5 of the 100 times would you have 5 in a row.
For every 100 trials that you run, you'll average 5 with the given outcome. For every 100 trials that you run, you'll average 5 with the given outcome. So we can actually knock that down with any multiplier we want. For every 20 trials we run, how many should we get on average? 1. So if you look at what we got, it's not actually all that bad. We ran 1, 2, 3, 4, 5, 10, 15, 27 trials. And we got 2 occurrences of head, 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 head. That's not bad. That's about 1 in 20, isn't it? It's a little high, but we only did 27 trials. We haven't gotten a chance to look at Faith's over 100 trials thing, have we? Good. Very nice, sister. Very nice. So in other words, I don't think we saw too many instances of H. Does that make sense? Kelly's looking at me like, no, I don't buy that at all. No, you're not. Okay, I thought you were building a counter offensive, which is okay. It's totally fine. Anybody still think that's too many H's, especially because it was the first one we saw? Maybe. See, it's hard to measure whether something is random or not. It's hard to look at this and be able to say, yes, it's random, or no, it's not. For example, are there too many of these HTTHHs? Are there any more of those up there? There are. You guys see them? HTTHT. This is different only by the last flip, yes?
That one, HTTHT, is over and over. It's 1.
It is! HTTHT.
3, 4, 5. Yeah.
Oh, there's one.
Yeah. There's like 6 or 7 up there.
Nope.
Right there.
There.
Right underneath it, too. No, that's...
So, a pattern would be the opposite of randomness, yes? A pattern would be allowing something to creep in that explains the underlying nature of occurrence of data. I screw with my poor son's kindergarten class on Friday. I volunteer every Friday morning from 8 to noon. And they played hopscotch last Friday because it's getting close to the end of the year, and it was day H. It's hopscotch. So I was in there for a couple hours with them. And they were playing hopscotch, and I could tell they were getting bored because they started jumping backwards, jumping on one foot. I'm like, someone's going to break their leg in here. So I said, that's what I'm going to do. I downloaded a random number generator on my iPhone. So I'm going to call out random numbers, and you guys got to jump to random numbers. And then it became a game, because then hopscotch boards go from 1 to 10, and they wanted to get 10 from the beginning every single time. Get a 10, get a 10. I'm like, it's random, kids. They're like, get a 10. I'm like, it's random. I'm like, I know you're 6. And then when I get like 3 10s in a row, they're like, you see, you got 3 10s. And I'm like, how do you explain that concept to a 6-year-old? And I decided you can't. They have no idea. All they know is they want to jump far, and 10 and 9 gets that. But I think you guys can totally get it, right? The idea that even though this seems like a very odd thing to start off with, H, it should occur X% of the time. Now actually 5% is a little high. It should actually occur roughly 3% of the time. Now how do I know that? Well, only because of a problem I just helped a couple of you guys do about an hour ago. This is related to a problem on your project, which is due on Wednesday. Remember the project where I asked you guys to write down all the possibilities if you're guessing at a true-false question on an exam. CWs, I think I had you do that. Well, guessing at a true-false question on an exam is just like flipping a coin, isn't it? If you're truly guessing, it's just like flipping a coin, correct? Should be. That's one way to actually help you guess if you're truly guessing. Flip a coin on the side. Heads true, tails false. How many outcomes? We know there's 32 of them. If you don't know, that'll kind of help you on the project, except it doesn't help you actually list all the outcomes out. But of all those 32 outcomes, only one of them is CCCCC, which would be heads, 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 heads. Only one of them is tails, tails, which is www on your project. So 1 in 32 is about 3%-ish, give or take a tenth of a percentage point there. So my next question again is this, so we had a vote that HTTHT was a little too much, yeah? Maybe this was the one, I think this is what you say,
I
Carrie?
think, now I'm looking at it, I think it's the HHT.
So can we metric any of those? Well, yeah, because any of those should happen 1 in 32 times. But why didn't anybody jump on this one? Like the HHHHHs. What's different from here to here? What, Faith, go.
The first one looks consistent.
It looks more anti-random because there's the absence of tails. When you flip a coin, the 50-50 creeps into our mind, doesn't it? The 50-50 creeps into our mind. When you see no tails at all, you immediately go to, ah! There's something not right about that. Whereas this, right here, has, if you will, enough heads and tails. Did anybody put up 1 and 4? Look at that.
1.
Only 1! Right here.
Well, there's another one right
Oh, there are 2? Right here. These 2. Now, there should be roughly, each one of those also only occurs roughly 3% of the time, 1 in 32. However, there are 5 different ways to have 4 tails and 1 head. It could go heads, tails, 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 tails. Tails, heads, tails, tails, tails. Tails, tails, heads, tails, tails. Tails, 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 heads, tails. Tails, 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 heads. Just like there would be 5 ways for this one here. Which means we probably saw too few people put up 4 and 1. We saw an awful lot of 3 and 2, didn't we? An awful lot of 3 and 2. But the 4 and 1 seems a little shy, doesn't it? The 4 and 1, there's 3 of them, but that still seems too shy to me, doesn't it? Because there's also 3 alls, right? There's 3 flushes. There should be 5 times as many, according to probability. There should be random probability. There should be 5 times as many 4 and 1s. Isn't that wild? So something in our mind has a hard time generating random numbers. Don't feel bad. You're human. You're not designed to be random. If you were random, our species would have been wiped out 10,000 years ago. We're kind of the opposite of random. How do you decide when to eat? Randomly? No, it's a pattern. You get hungry, you eat. Right? You get cold, you put clothes on. You don't decide what to wear based on randomness. Flip a coin. Ah, it's -20. Put the Speedo on. No! You don't dress randomly. You don't eat randomly. You don't walk in the middle of the road randomly. It's the opposite of randomly, right? But the trick is statistically, randomness is important. You need to make decisions randomly sometimes when you're setting studies up. More on 243 and 244. But before we get into that, this is about 200 trials-ish. 5 times roughly 20 is about, well, it's about 100 actually. It's shy of 200. So what I got here is I set up a true, well,